Okay, so this is the demonstration for little UIK API. So here's main, and it's just got some stupid functions in it, but it's kind of like how you would use the kernel here. So the first thing we do is just set up the ports like usual, and then we make this call to UIK initialize. And so I'm in a debugger mode right now. So I guess I can just start executing. So in the call to UIK initialize, what that does is it basically sets up the timer, and right now it sets it to a 1 megahertz clock, and it sets the CTC value to the tick length, which we pass it in, which is a 16-bit value, and right now we have it set to I think like 1,000, which is basically 1/100th of a second. So, and then also another thing the UIK initialize function does is it adds a task, and in this case it adds the idle task. So, so it does this for every task that's added, but let's just go through the idle task once to see kind of how what add task is doing. So add task just, let's see, it sets up the buffer, and then we have this control block down here, a task control block, and right now it's just an array that's in data memory, so it's kind of a stupid data structure, but it keeps track of the state of a process, the priority of a process, and how long it has to wait if it's being delayed. So here when we add it, we just initialize all those values. We also set the stack pointer to this very first value right here, so the bottom of it. And right now we just put 0x11 at the bottom, but we will overwrite these values. 0x11 and 0x22 will be overwritten. 0x33 will not be overwritten, but it's still there just kind of to debug. So the next thing is we push on the address of the executing function onto the stack. So when we call reti, this should be the value that pops off, and so it should point to, in this case, idle task, because this is the one we're adding. And then we simulate a call of save context, because what's going to happen next is we will be calling restore context and save context. So these two functions, the restore context, you can see, just pops off all the values to the stack. It pops off the old buffer and then all the values in the sreg, all the registers. So we want to simulate that call because we haven't actually called that. This is restore context, and usually it's called after save context, but right now we haven't called save context up, so we're just kind of simulating all this for the initialization. So here you can see we're just like setting all the registers up, registers 0 through 31. And then after we push all the registers, what we do is we store the address of the stack. So this is the top of the stack, but we want to store that at the bottom, at the very two first places. So these places right down here, these 2 bytes. So we're storing that location there, so it's at a known place. And we return the task ID. So so that's that. And then we go back to we should go back to main. So we're over here in main now, and it'll to add these other tasks. This is kind of the same thing what we just did with our idle task, but this is now task blinky 2, and task count. So all these will be have those dummy stacks too right off. So we can just skip those. I have a breakpoint now at start RTOS. So this is the next place we're going to jump, is this start RTOS function, to see what it does. So running to there. Start RTOS sets, well, the first thing it does is it sets the TCB of 0, which is our idle task. It sets its state to ready, which setting the state to ready doesn't really do anything other than just say it's ready. It's really the same thing as initialized, except for a dummy value. Then we set the stack pointer to point to the idle tasks stack. And then we finally enable interrupt. So now things can be interrupted. So one thing is this restore context. This is the first call to restore context, and we set all these values kind of manually. So what should happen, if you remember, if we go back up to when we set all these, we set them to like 00, 0000020304, blah blah blah. So they're kind of known values. So what should happen after this restore context is we should have all these values set because we're popping them off the stack. So this took a while to figure out, but sure enough, you can see all our values are set to all the registers here. Then we have this ASM volatile RETI. Start RTOS is a naked function, so we have to do the return and well, what's it called? Whatever. We have to do the setup and the return ourselves. And so this RETI enables interrupts because, in addition, it will pop off the next value on the stack, which happens to point to our idle task. But in general, it'll point to whatever task. So if we step again, we actually jump to idle task instead of back to main, which is what called us. So we should be here for a little bit until our next interrupt. So if we just press run to the next breakpoint. So this is our interrupt. This is basically our tick. It's our output compare 1A, so every 1/100th of a second this is called. And then we call our save context, which is the opposite of restore context. So save context will just push all the registers and our current TCB. So we do that, and then we do our tick logic. So tick is called, which is down here, and what tick basically does is it looks at all the tasks in our TCB and finds the one with the highest priority that's ready to go. And another thing it does is it updates all the delays. So there's a bunch of functions that have delays in here, and it lessens them by 1. So if we go back to that, now if you look at our debugger here, I'll drag this over. Our current task is now 3 because it has the highest priority. If we should return now, instead of to our idle task, we should return to task 3, which well, I guess we'll find out what it is. I can't remember. I guess it's a task count. So what this one, it counts from 0 to 8 and saves that to port B. And so this will execute. Then it calls this delay function, so it kind of goes to sleep, and the next one is called, and so on. So anyway, if you come up here, we can look at this guy in action. So if you look at the bottom here, this one is just counting to 8, so this is the one that was called first. But also in addition to that, we have these two processes up here. This one on the top counts a little faster than the one that's LED 6. So they're kind of really simple tasks, but they get the job done and they switch context. So, alright, thanks.